RC, this you can call RB, and this is a NPN transistor. Beta of a transistor given, and it VC 5 volt. Find the value of RB. Okay, now nothing to do with the transistor working or characteristics. So it's all about the writing KCL and KVL. So what are the KCL? So look at first the arrow of the emitter. The emitter, you have this emitter current. So from this, you will get the IE. Then there's a collector current and there's a base current. So then first, what is the equation? IE equal to IC plus IB. Then, so further next again go for plus minus. On what basis? So the collector current here, IC. This will be IB. And here is what? This will be IE. You'll get confused. Okay, because this has to be IE, this is the thing. Right, loop equation is asking to calculate. This will be VC and this will be VB. This will be value of VB. Okay, let's write loop equations. What do you mean by loop equation? This is a KCL, the loop equation from here, plus 10 minus ICRC minus VC equal to 0. Then one more loop equation from here. Then let's solve. What we'll get, we'll see. Plus 10 minus ICRC minus VC equal to 0. We know value of RC 1 kilo ohm. So VC is given 5 volt. So 10 minus IC, this will be 1000. VC is 5. IC is equal to 5 milliampere. Then we have beta. So beta is equal to, what is the formula? Beta equal to IC by IB. Current gain and alpha is IC by IE. Can you remember this? These are the set of formulas. In common base configuration, the alpha will be IC by IE. So there's a beta what we're getting. So now what we have beta. Beta is how much? 100. 5 into 10 to the power of minus 3. This IB. IB will become 50 microampere. Keep it. Okay, let's write one more loop equation from here. Okay, are you getting now? This one, sir. How do you assume this direction of current? This is something very important. If you can get the direction of collector base emitter current, I think problem is over. I feel like, say it's an NPN transistor. The arrow will be given. The direction of arrow will give the direction of emitter current. Okay, if the emitter current leaves emitter terminal, the base and collector current should enter. So from the KCL, IC equal IC plus IB should be equal to IE. Applying KCL. Then, okay, this currents, from there you give polarity, from current density. Then apply KVL. So I'm starting for this now, plus 10 minus IBRB minus VB. From base to emitter, you are moving. VB equal to 0. So the loop equation will be plus 10 minus IBRB minus VB equal to 0. Do we know RB? What is RB equal to? 10 minus VBE by IB. Do we know IB? As from here, so 10 minus, this will be 0.5 by solving will this will be 9.5 by 5 into 10 to the power of 19 or 190 kilo ohm. Please look at this. These are the types of numericals what you can expect in exam. Nothing to do. So in fact, in spite of telling students several times, transistor circuits are nowhere related to the theory what you learned. KCL, KVL. Okay, now a few questions I'll ask you here. Is it transistor is in active region? What do you mean by active region? What do you mean by active region? So active region.
Gain is maximum.
Active region. Collector base junction should be reverse biased. Base emitter junction should be forward biased. I'm very sure about base emitter forward bias. How do I can say, because VB I know. How do I ensure that collector base junction is reverse bias? I'll calculate the potential drop VCB. Can we calculate potential drop VCB? Yes, there are several things are there. You can go for one more loop here. One more loop here. So here, let me indicate. This is the VCB. Collector voltage. So let's write loop equation. the loop equation is here. Getting this one. So this should become equal to minus ICRC minus VCB plus IBRB equals 0. Anybody value?
0.5.
Plus, sir?
Yes, sir.
Okay, now VCB I got 0.5 volt. So what does it mean? Collector is N-type, base is P-type, and collector is more positive than the base. So therefore, collector base junction reverse bias or forward bias? This is a reverse biased. So I'm very sure that collector base junction is reverse biased as we see. So JCB is in fact a reverse biased. So I think satisfied, no condition like this. You can check the transistor is in active or saturation or cutoff with the help of this condition, sir. Or sir, any other any other approach? Can you write this VCE as I think check this VCB value. Is it 0.5? I doubt. Check it once.
4.5, sir. Sorry.
That's what I'm saying. No. Okay. Now look at this one. VCB. We can also use this method. What is VCE? VC given 5 volt. Second approach. All these are not concepts. These are just like a different approaches, different methods. Okay, you can write this. There's no harm. Books, they didn't discuss anything like this, but it's a very useful thing, that one, because most of the numericals, no, the VB will be given and you can calculate VC. Directly check VCB. No need to go for this KVL. That's what you can save a lot of time here to check whether the transistor is in active region or not. No, there's two methods is what I'm telling. One by KVL, other by just VC equal to VCB plus VB. I think the second method is really going to help you a lot in exams, provided if you know these two quantities. Anything transistor characteristics is needed here? Nothing, no. There is no use of this. Now let's try to change here. Here only if I bring one resistor, what will happen? That's the same thing. The loop equations will continue. Here I'll bring one cell.